Hey everyone, welcome to our capstone project. I'm Michael, this is Aaron. We are adapting Remedion's patent-pending hydroelectric water purification system design for residential applications. Our technical director is Alexander Tompkins. He graduated from URI in 2022 with a biology and marine affairs degree. Following his time as a student here, he designed and filed patents on food production and water treatment systems designed to remove pollution from source water and produce pollutant-free alternative food and water products, after which he founded his startup Remedion to deliver his clean technology. Like I said, I'm working with Aaron. He's the electrical engineer, actively working on the electrical and firmware tasks for our project. And like I said, I'm Michael. I'm the computer engineer, actively working on our firmware and software aspects of the project. So our mission ultimately comes down to remediating the pollutants in your diet. We accomplish this by providing sustainable solutions, innovative technologies, and pollutant-free products. Company overview: Remedion is a clean tech startup with 4 patent-pending processes that remove pollution from source water, then repurposes the pristine water for aquaculture, hydroponics, and direct human consumption. Currently, Remedion is working towards commercializing their pure water bottling technology by launching Remedion Water, a clean bottled water free from man-made pollutants. For our project, Aaron and I are taking Remedion's HWPS municipal design and applying it to whole home water purification systems. So the project motivation for our project consists of 3 parts: clean water at home, reducing electrical costs to purify water, and sustainable living. Due to unknown pipe composition and loose regulations on emerging contaminants, the consumer is entirely unaware of their water's quality. Drinking polluted tap water, cooking with it, and bathing in it are all vectors of exposure to harmful contaminants and carcinogenic pollutants. Since purifying water demands a substantial amount of power, we have integrated power recovery systems within the HWPS. This will allow users of the HWPS the ability to purify their water without increasing the user's electricity consumption. By consuming, bathing, and cooking with the cleanest water possible, we are promoting a more sustainable lifestyle. Users of the HWPS safeguard their well-being by removing the legacy and emerging contaminants from the home's water. Through our project, we aim to alleviate the long-term negative health effects from this source. So our company and economic impact: we want to establish ourselves as a leader in advanced water purification through getting sales from filter replacements and system sales, ensuring long-term success for the company, which will ultimately be passed down onto the consumer in terms of reduced household energy costs. The anticipated best outcome for Remedion is that we bring this HWPS as a whole home solution to the market through pure water assurance and energy and sustainability. Our team technical accomplishments to date include energy and pressure optimization and 3D model development, which was done on Aaron's part. And on my part, I've done inline sensor and software determinations for the Capstone and companion app, and I've worked on developing our UI. For the block diagram for the HWPS, pretty much have the water source coming in from the street, and then we're going to measure the input to determine the water quality initially, and then the water will flow through our 5-stage process in the HWPS. At the 4th stage, which is sub-micron separation, we'll actually measure that output and compare the difference to allow users to determine their water quality. So the software and firmware technical accomplishments on my end include selection of our software, which was Flutter, for integration across platforms, including Google and Apple, and our water quality monitoring, which was done through TDS sensors. We decided to use these as they measure in total dissolved solids through parts per million. And like I said, I've been working on the UI for our app to provide the user with that specific data in terms of filter replacement and water quality. So like I said, on the left, it's a pretty basic water quality page. We just have input, output, and a chart where users can ultimately determine what these numbers actually mean. And on the right, this is an updated layout I'm currently working on to allow the user to easily have accessibility to their filter replacement and water quality. This is a TDS sensor flowchart, allows users just to ultimately determine what their water quality means based on that parts per million number. If it's poor water quality, it'd be above 250, and we alert the user through the app to let them know that maybe a part needs to be replaced or a filter has gone bad. So remaining responsibilities on my end include finalizing our app, providing an interactive user interface within the actual system, integrating the TDS sensors into the HWPS for that water quality extraction, and ensuring user control and safety. I'll pass it over to Aaron for further details on the block diagram.
Hi, I'm the electrical engineer for the project. My work encompassed understanding the various components of the system and integrating them together. Starting from municipal water source, the water moves into stage one, which allows for the capture of particulars greater than 5 microns. A micron is another way of saying micrometer. The second stage is absorption of chemical contaminants, i.e. chlorine. The third stage is biological sterilization. From here, it separates through the submicron filter into the 300-gallon water tank for household distribution, and the fifth stage, the remediation stage. After the fifth stage, the water will be fed back into the system through a turbine, so there's a closed loop ensuring no waste of water. The water turbine will help supplement energy needs of the system, the water pump, which ensures consistent water pressure delivery to the home. I was in charge of creating a 3D model, developing system specifications, and power system design. The 3D model allowed us to be able to discuss and convey ideas regarding the format and flow of the system. It was also used as a deliverable for our engineering advisors in the company to create an initial model for testing. The system specifications component of my job involved understanding the impact of flow rate, how the water moved through the filter stages, and what kind of outputs we could expect. This involved analyzing water pressure and taking into account the various conditions that the system would be installed in. These constraints, among others, led us through various design stages to ascertain the ideal setup which would accomplish our goals while keeping costs down. Integrating the power system into the design required knowledge of hydrodynamics. There was only so much energy in the system to capture and repurpose. So we had to be diligent about where we were getting the energy from in the system and maintain awareness about how extraction of energy affected the system. The overall idea is that the turbine captures energy, the water pump consumes energy, and there's a battery to bridge the divide. By April of 2025, we will have a physical realization of the battery, water pump, and turbine to experimentally test, gather data, and fine-tune. This system will have been used to arrive at the final mass production model. Our key future technical accomplishments include working with company engineering advisors to finalize plans for mass production. Our confidence in this is high as we are in continual discussion with these advisors and they have ample resources to complete the mission. Hurdles include familiarization with the level of detail required for mass distribution and finalizing the cost to consumer and making sure that cost is reasonable and affordable. We would like to thank Dr. Sunak for connecting us with Alex Tompkins and for this project and for the whole Capstone experience. We would also like to thank Alex Tompkins for allowing us to take part in adapting Remedion's hydroelectric water purification system for residential applications.